I welcome you all to your Mathematics E-lesson with Springdale Senior School. This is your fourth E-lesson with us. Today, we will be continuing with the topic which we have started last week, that is linear equations with one variable. As we all know, linear equations are equations with one variable and highest power of variable is 1. Few of the examples are listed below. Now we will start with brain exercise. You all are able to solve equations with one variable easily now, but this is not the only way that questions on this topic can be asked. You can be asked to verify the solution as well. So let's start with reading of the statement. Solve the following equations and check your solutions. Example, 2x minus 3 equal to x plus 2. I'll collect all the variables on left hand side, hence the solution will be x equal to 5. For the verification, I will fill the value of x in the left hand side as well as in the right hand side. So 2x minus 3 can be written as 2 multiplied by 5 minus 3, that is 10 minus 3, which is equal to 7. On the right hand side, x plus 2, that is 5 plus 2, which is equal to 7. So left hand side is equal to right hand side. Hence it verifies our solution. Next, 5b plus 6b equal to 33. For the solution part, 5b plus 6b is equal to 11b, which is further equal to 33. 11 is getting multiplied. In the next step, 11 will get divided. So b is equal to 3. For the verification part, again, we will substitute the value of b in left hand side as well as in right hand side. Here in the left hand side, it is 5b plus 6b. So it will be 5 into 3 plus 6 into 3. That is equal to 15 plus 18, which is equal to 33. Since we are not having any variable in right hand side, so we will copy down the number as it is. So left hand side is equal to right hand side and hence it verifies that our solution b equal to 3 is correct. Now we will be discussing about distributive property. A into B plus C is equal to A into B plus A into C. We'll be applying the distributive property in the next sum. That is 6 into A minus 1 equal to 3 into A plus 4. Here I'll be applying the distributive property on both the sides of equal to sign. For the solution, 6 is multiplied with the A, that is 6a, and 6 is multiplied with minus 1 equal to minus 6. And on right hand side, 3 is multiplied with the A, 3a. 3 is multiplied with plus 4, that is plus 12. So I will shift minus 6 to right hand side. It will become plus 6 on right hand side. So 6a is equal to 3a plus 12 plus 6. That is 6a is equal to 3a plus 18. Now 6a minus 3a is equal to 18. Hence 3a is equal to 18. A is equal to 18 divided by 3. So a is equal to 6. Now for the verification, I will substitute the value of a in left hand side and right hand side again. So left hand side, 6 into bracket a minus 1. 6 into bracket 6 minus 1. I'll be applying the rule of Bodmer's here. So I will solve the bracket first and then will proceed with the multiplication. 6 into 5 is equal to 30. Similarly, in right hand side, 3 into a plus 4, that is 3 into 6 plus 4, that is 3 into 10 equal to 30. That means left hand side is equal to right hand side. Hence, it verifies our solution. Now, we will be discussing about consecutive integer problems. Children, consecutive integers are those integers which are coming one after another, like 15, 16, 17, 18, 19 and so on. So, we people will be discussing about the word problems related to consecutive integers here. Let the three consecutive integers be 5, 6, 7. So in general, we can say that the second one consecutive integer is more than the first one by 1 and the third consecutive integer more than first one by 2. So let the first integer be n. Let the second integer be n plus 1. Let the third integer be n plus 2. So three consecutive integers can be n, n plus 1, n plus 2. Here we can further bifurcate the consecutive integers in two categories: consecutive even integers, consecutive odd integers. Consecutive even integers, few of the examples are listed below: 2, 4, 6, 8, 10, 12, 14, 16 and so on. Here we people can see that the second consecutive even integer is more than the first one by 2. And the third consecutive even integer is more than the first one by 4. So let the first integer be n, the second be n plus 2 and the third be n plus 4. So in general we can say that three consecutive even integers are n, n plus 2, n plus 4. Consecutive odd integers. Consecutive odd integers are also differ by the same number 2 from each other. Few of the examples are 1, 3, 5, 7, 9, 11 and so on. Here again we can see that the second consecutive odd integer is more than the first one by 2 and the third consecutive odd integer is more than the first one by 4. So let the first integer of the consecutive odd integers will be n. The second one will be more than the first one by 2. So the second one will be n plus 2. Again, the third one will be more than the first one by 4. So the three consecutive odd integers will be n, n plus 2, n plus 4. Now we'll start with the discussion of a sum. Statement: sum of three consecutive integers is 24. Find the integers. So first of all, we will assume three consecutive integers. Let the first be n. Let the next one will be n plus 1. Other next one will be n plus 2. Since the sum of these three consecutive integers is 24, that means n plus 1 plus n plus 2 is equal to 24. That means 3n plus 3 is equal to 24. So 3n is equal to 21. That means n is equal to 7. We have to find out the three consecutive integers. That means we have to find out the numbers 7, 7 plus 1 and 7 plus 2. So three consecutive integers are 7, 8 and 9. That's all with the sum. Coming to the next sum. Sum of the three consecutive even integers. Sum of the three consecutive even integers is 54. Find the integers. For this solution, let the smallest even number be n. Let the next one will be n plus 2 and the other one next will be n plus 4. Since their sum is equal to 54, so that's why n plus 2 plus n plus 4 is equal to 54. That means 3n plus 6 is equal to 54 and 3n is equal to 48. So n is equal to 48 divided by 3 and n is equal to 16. So the three consecutive even numbers will be 16, 16 plus 2, 18, 16 plus 4, 20. That is 16, 18 and 20 are three consecutive even numbers which are summing up to 54. Consecutive multiples of 5. Few of the examples are 5, 10, 15, 20, 25, 30. Students, here you can see that the second consecutive multiple of 5 is more than the first one by 5 and the third consecutive multiple of 5 is more than the first one by 10. So in general we can say that the three consecutive multiples of 5 are n, n plus 5 and n plus 10. Consecutive multiples of 11. Examples of the consecutive multiples of 11 are 11, 22, 33, 44, 55, 66 and so on. Here you can see that the second consecutive multiple of 11 is more than the first one by 11, and the third consecutive multiple of 11 is more than the first one by 22. So in general we can say that the three consecutive multiples of 11 are n plus 11 and n plus 22. Now we will try one sum related to it. Statement: the sum of three consecutive multiples of 11 is 363. Find these multiples. For this solution, let the three consecutive multiples of 11 are n plus 11, n plus 22. And since their sum is equal to 363, so n plus 11 plus n plus 22 is equal to 363. That means 3n plus 33 is equal to 363. And 3n is equal to 363 minus 33. And n is equal to 330 divided by 3. And n is equal to 110. We were supposed to find out three consecutive multiples of 11. So that means the three consecutive multiples of 11 would be n plus 11, n plus 22. That means 110, 121 and 132 are answers. So students, in the end, I would like to tell you to attempt all these sums as well as the sums of the assignment given to you neatly and submit it back to your concerned teacher well on time. Thank you and take care of yourselves.